Hello then, my enthusiast learners. We are now here in the next lesson that talks about Heron's formula for the geometry lesson. What is this Heron's formula is all about? Don't forget first to click the notification bell and click also the subscribe button for the future lesson to be updated, okay? Now, let's discuss what is this Heron's formula. Take note that we have the basic knowledge in dealing with this, in getting the area of a triangle is we have 1/2 base times the height. And it seems that we need to do further that is something we have to cater everything. Like, what about if the height is unknown? Or just we say, if we have here this kind of a figure wherein all the sides are known but the height is not known. Or just here, because take note, this one is the height of a given triangle. But take note that we don't have any height at all. What we have here is the value of A, B, and C, wherein this figure is not a right triangle. It's just a scalene triangle. Take note with that. That one is a scalene triangle. Now, how to cater with everything here? To find the area, we require the height of corresponding to the base. But the height, since the height is not known rather, so Heron now discovered a formula to find the area of a triangle, wherein Heron is coming from 10 AD to 75 AD, and is an encyclopedic writer in applied mathematics, gave a formula for finding the area of a triangle when we know the lengths of these three sides. Then this one now is called the Heron's formula, after Hero of Alexandria. The Heron's formula relates to the sides given, the sides of the lengths, given the three lengths that we add three sides of the given triangle, then given the perimeter and an area of a triangle. So this concept is coming from this site. Thankful for that one. Credit to the owner for this. And now, what we do further or getting the step in working for the Heron's formula is just first calculate the perimeter first, then divide by 2. That one is our semi-perimeter. All the sides divide by 2. Then where A, B, and C denoted by the sides of the length of the side of the certain triangle. Then after which, the semi-perimeter is represented by S. So to substitute the formula, we calculate the area of a triangle by means of taking the square root of the semi-perimeter times the semi-perimeter minus this one of the side A times semi-perimeter times side B, minus side B rather, times semi-perimeter minus side C. Now, this is not the formula that we have. For us to know further about this kind of formula, we have here a certain example. Find the area of a triangle. Take note that the given now is not specified what kind of triangle. So therefore, this is not considered anymore a right triangle, whose sides are 12, 14, and 16. We don't have any height at all. So for this is we're going to get the perimeter. So A plus B plus C. And we come up with 12 plus 14 plus 16. So we come up with 42 as the sum. So we now have here 42 centimeter. Yes, it's a 42 centimeter. So we now have here S, which is the semi-perimeter. A plus B plus C all over 2. And we now have 42 divided by 2. And we come up here, semi-perimeter is 21. So from that, the area of triangle now, using the Heron's formula, so we now have here semi-perimeter times semi minus A side, semi-perimeter minus B times semi-perimeter times C. And we now have here, replacing all those values that we have, 21 times 21 minus 12 times 21 minus 14 times 21 minus 16. 16 here. This is 16. And we now have square root of 21 times 21 minus 12, and that is 9. 21 minus 14, and that is 7. Times 21 minus 16, and that is 5. Okay? So, we now have 21 times 9 times 7 times 5. And take note that this 21 here is just the same as 3 times 7. So, therefore, we now have 2, 7, and another one, 9. So, what we now have here is, take the product of all. We have 20. We have how much? 21 times 9 times 7 times 7 times 7 times 5, and we have 6,615. Okay, kindly check your work if it is correct. Then we have to compare. 21 times 7 times 9, or 9 times 7 times 5, 6,615. And then we have approximately, take the square root, we have 81.3327. So since we don't have, take note that we have to be careful in working without this, since it is not rounded up, but most of the time what we have here is we are going to round up to the nearest hundredths our answer. So we now have here 81.33 centimeter, square centimeter, because this is the area. So the area that we have now of a certain triangle, given the sides 12 centimeter, 14 centimeter, and 16 centimeter, is 81.33 centimeter square. Okay? Now, let's proceed to example number 2. The example number 2 that we have is, find the area of a triangle, two sides of which are 13 centimeter and 14 centimeter, and the perimeter is 42 centimeter. So we now have here, given perimeter is A plus B plus C. So since the perimeter is 42, so we now have here 42, 13 plus 14, and we have here C. So we now have 42 is equal to 27 plus C. For us to be able to cater this out, to find the answer for the value of C, is we're going to subtract 27, negative 27, both sides of the equation. So 42 minus 27, and that is 15. Then this is just 0. So we now have here C is 15. Now, since we are looking for the area and it is not known that we have it is not a right triangle, so we have to cater A, B, and C, because from the formula that we have of the Herons, we have to situate that the A, B, and C are known. And so the semi-perimeter that we have is 42 divided by 2, and that is still the same with 21. So the area now of a triangle is equal to the using the Heron's S minus A, S minus B, and then S minus C. And so we have S now here is 21 times 21 minus 13 times 21 minus 14 times 21 minus 15. And so we have square root of 21 times 8 times 21 minus 14, and that is 7. 21 minus 15, and that is 9. Is it 9 or 6? 6. Okay, so we have that. And so we have 21 times 8 times 7 times 6. And we come up with the answer of, we have here square root, is it correct? Square root of 7,576. 7,056. Again, 21 times 7 times 21 times 8 times 7 times 6. So we have here square root of 7,056, and that is, we have square root of 84 cm squared. So the area now that we have is about 84 cm squared. Okay, let's proceed now to the next example. Our next example is an isosceles triangle has a perimeter of 50 cm and each of the equal sides is 15. Find the area of the triangle. So working with this, so we now have here perimeter is A plus B plus C, and we now have here the perimeter is 50 with the side A and B. Consider this A and B is 15 because in an isosceles triangle, two legs are equal. So we just considered the A and B as our leg, so they are now 15 and 15 plus C. And so we have 50, which is 30, equal to 30 plus C. So subtract both sides by 30 for us to make it 0, this one. So what is now here is 20, which is equal to C. So the semi-perimeter is, we have 50 divided by 2, and we have here 25. So the area now of a triangle using the Heron's formula is S minus A, S minus B, S minus C, is we have now square root of 25 times 25 minus 15, 25 minus 15, the other leg, then 25 minus 20, and we now have here 25 times 10 times 10, this is 20 times 5, and so we have 25 times 10 times 10 times 5, and we have 12,500 as the product. So square root of 12,500. So what is the square root of 12,500? And we have approximately 111.8034. So therefore we could say further, we are going to round off to the nearest hundreds, and we now say that this is just 180 cm squared as the area of a triangle. Okay, the next example is, we have the perimeter of a triangle is equal to the perimeter of a triangle plot is 360 meter, and its sides are in the ratio of 10 is to 12 is to 14. Find the area of a triangle. So we now have here the perimeter of a triangle, which is A plus B plus C, and it seems that its perimeter is equivalent to 360 with the ratio of it, the side is 10 by 12, 10 is to 12 is to 14. So we now have here 10x plus 12x plus 14x. So 360 now is equal to 22. 10 plus 12 is 22 plus 14, and we have here 36x, right? And to get the farther for x is we are going to divide both sides by 36, and we come up here that the x farther is 10. So now we have 10x, and that is 10 by 10, 10 times 10, and that is 100. 12x, and we have here 12 times 10, and we have here 120. 14x is equal to 12 times 14 times rather, this is just 14 times 10. Okay, this is just 14 times 10, and we now have here 140. All the while the sum here is 360. So using the Heron's formula for us to get the area of a triangle, so we now have here semi-perimeter, by the way, is 360. S now is 360 divided by 2, and that is 180. So 180 times 180 minus 100, then we have 180 times 120 minus 120, then 180 minus 140. So we now have here 180 times 80 rather. Okay, you have that times 80 times 60 times 40, and so we have 180 times 80 times 60 times 40, and we come up here as square root of 34,560,000 using the calculator, scientific calculator. And if I take the square root of that, so it is just approximately 5,878.78 meter square. This is now the area that we have. Okay, so where do we get the 10x plus 12x plus 14x? Take note that the sides are in that ratio, so we're going to add it and represented that x there is the common factor of all the ratio of the sides that we have. Okay, so the area now is 5,878.78 square meters for the number 4. And for the last example, a triangle has sides 9 cm, 12 cm, and 15 cm. Find the length of the perpendicular to the opposite vertex to the side whose length is 15. So in this case, we now have here, like for example, if we have this kind of figure, then consider this one is just a scalene. This is 12, this is 9, and this is 15. Then take note that find the length of the perpendicular from the opposite vertex to the side whose length is 15. So therefore we have here this one, the height. This is the h. Okay, how to get the h? That is the big question. That is what we asked for, what we are dealing about. So first thing that we should do is that we're going to have the perimeter first, and we have here 12 plus 9 plus 15. So 21 plus 15, and that is 36. So P is 36. So S now is 36 over 2, and that is 18. So what we have now here is that the area of a triangle through the use of the Herons. So S minus A, S minus B, S minus C. S times S minus A times S minus B times S minus C. And we have here 18 times 18 minus 9 minus 12, 18 minus 9, and 18 minus 15. And so we have the square root of 18 times 18 minus 12, and that is 6. 18 minus 9, and that is 9. 18 minus 15, and that is 3. Okay, that is 3. Take note that one. So we have here 3. So what we have now here is 18 times 6 times 9 times 3, and that is 2,916. And take the square root of that, and we have here 54 as the area of a triangle. And take note that the area of a triangle is also the same as 1/2 base times the height. So therefore we now have here another set of situation wherein we're going to find it out the height. So we have 1/2 times base, which is 15, times the height. Where is 15? Where can we get the 15? Because of whose side? This one here, the base times the height. The base of 15. And we have here 54. So now we now have here 7.5. H is equal to 54. Divide both sides by 7.5. So 7.5. And we come up with 54 divided by 7.5. So H, therefore the height of the height that we have now is 7.2 centimeter. Okay, so therefore the height now is 7.2 centimeter in this given. Okay, so we are done now in discussing all the sort of example and dealing with the Heron's formula. Hope you enjoyed this and keep on watching for the video. Don't forget, just click the notification bell and subscribe and like, and give some comments for the future lesson for you to discuss with me as your teacher. And take note, your teacher Dexter Coraje is just here for you to help. Do not forget to have your mind to be in touch in mathematics. So hold on, keep on watching. See you then for this video. Goodbye for now.